So for this video, we're gonna go over some more of 2D kinematics and then review the practice problem number 21. Okay, so we'll start out with just the same ideas that we had before. As you can see, I'll zoom in on it a little bit. So derivative of x position or displacement is velocity, derivative of velocity is acceleration, integral of acceleration is velocity, integral of velocity is displacement, and then we have our two little equations right here. And like I said in a past video, one easy way to find these values is when the velocity is 0. So for example, that would be at the top of a projectile motion at its maximum height. That's when the velocity in the y direction would be 0, which would completely get rid of the term, or we just allow us to know a term. So it would be 0 equals blank. So write these equations down and know them. Now, second part of what this lesson is about is the idea of splitting up a vector into two components. So, for example, let's say we have projectile motion, but the projectile is shot in at, let's just say, a 30 degree angle at a velocity of 40 meters per second, right? So now we know that the velocity of the x direction is going to stay constant. So we want to find the x and y components of this vector, where this is the positive x and this is the positive y direction. So this is a positive, but this vector is in a positive direction. So all we have to do to find that is use this angle. So the component for the velocity in the y direction is going to be, sorry, my bad. This is the positive y direction right here, and this is the positive x direction down here. So all we're going to do for this is for the positive x direction, it's 40, it would be 40 cosine and then the angle, which is 30, and in the y direction right here, it'd be just, instead of cosine, it'd be sine. So 40 sine and then the angle, which is 30 degrees. So now we're going to use this in our example problem, which is a cannonball is shot from the top of a 30-meter high hill at a velocity of 25 meters per second and an angle of 40 degrees above the horizontal, and lands on the ground below. The speed of the cannonball at the top of the path is most nearly. Okay. So what the information that we have for this problem is that the cannonball is shot at an initial velocity of 25 meters per second, but it's at an angle of 40 degrees, okay? So, and they also tell us that it's shot from a 30-meter, the top of a 30-meter hill. But that doesn't really matter because all they're asking us is the speed of the cannonball at the top of its path. So one thing to remember is at the top of a path, the velocity of the y velocity is 0 because it's just stopped going up and is about to start coming down. So to find the velocity at the top of this path, all we need to do is break up this component and find what is the x velocity going to be? And that's going to be our velocity at the top of the path. So, of course, again, we're going to break down this vector. So it's going to be, this is 25, and this is 40 degrees. So in the y direction, it's going to be 20. This is the positive y. This is the x. This is the x direction. It's going to be 25 sine 40 degrees, because that's our angle. But we don't need that because there's no, the velocity at the top of the curve is 0 for the y direction, whereas the x direction, the velocity stays constant, and we see that when we break up the components, we get 25 cosine of 40, and when you put that in your calculator, you'll get approximately 19 meters per second. So now let's look at our answer choices, and we see, right here for problem 21, answer choice C is 19 meters per second, which is rounded from 25 cosine 40 degrees. So that's our answer.